going to do or what we are going to see over here. You see, the project starts with understanding of what we are going to do as a GitLab pipeline over which we are deploying few jobs related to Terraform. It's a very simple use case where we are putting in few of the Terraform jobs to provision VPC over AWS Cloud. VPC is a network element that we have already covered in our AWS session. So what we are doing without going into AWS console, we are using the pipeline, the GitLab pipeline, and this could be a developer or this could be you or the DevOps engineer who is going to put in few jobs developed by the developer, and we are going to provision a particular resource, which is a VPC in our case. Clear? So what we do is before we run this pipeline with the Terraform jobs, we see that there is in the Mumbai region of this particular IAM user, which is DevOps Internship. Remember, we had created this IAM user while we had been onto our AWS session. And this is our account, Kalkey training. So we see in a particular region, there will be only one default VPC. Right now, this is the current state. So after this, we have designed our pipeline where we are running the job sequentially one after the other through a pipeline. This is an automated pipeline. I will not start with an automation. I will just for your demo, I will just show you how we switch between the completion of the first job, start of the next job, completion of the next job, start of the other job. So this is a pipeline. So where we are validating the Terraform scripts, then we are planning our resource, whatever the resource that we are going to create. And finally, we are applying this. After we apply this, we will check that there will be you see, there is a new VPC created through this pipeline job over into my AWS Cloud. Without once for all, I mean, without going to this, even for once into the AWS Cloud, we are not doing anything manually. So let's see that. For that, as we have seen that there will be your requirement of this. So we are going to run our jobs on a particular self-managed runner that we have already installed over the a particular server. Okay, on a cloud in the same region. So we have installed our GitLab runner, which was assigned to our project. That was linked, and through that runner, with the help of Docker, it will be able to run these jobs. So we are doing a self-managed GitLab architecture. Let us go to we are into our DevOps internship. See, this is our user, IAM user. We are in the Mumbai region. We are in this account, Kalkey training. And forget about this. This will come afterwards. This is our server. This is a EC2 instance that we have created already. But I have already created everything for you. This is just a demo. Okay, to see the power of pipeline, the GitLab pipeline that we have installed. So I have connected to this particular server, okay, which is DevOps Internship GitLab. It is running as a T2 micro into this particular availability zones, AP South 1A, which is Mumbai, and with a security group launch wizard 3 and with the key pair as DevOps Internship. Okay, we have connected over our putty, whatever connection. It can be through the Mac terminal, it can be through the Git bash, or it can be through your putty. So I have logged in. into this, and I can show you that I have already installed Docker. These are two important requirements. The Docker version is there, which is the latest version, and we can see you may not be knowing about the Docker. We will discuss that part. We are trying to see whether there are any containers right now. So we only have the Docker engine, basically because we need the runner now. So the runner is the GitLab runner. I'm interested to see whether the status, whether it is running or not. Yeah, we see the GitLab runner. The service is running up and running, and this is our server from which we need a runner. This is a self-managed runner, and that is what is asked from you when you join an organization. You do not go for a you SaaS managed GitLab runner. We are doing it ourselves, self-managed. Okay, so this particular runner, this, yeah.
Yeah, Mr. Devashish, I think we should we start the recording?
Oh, I'm very, very sorry.
I'm not
That was a
recording. I have
sorry.
started
Thank
recording.
you. Thank you. This was a lot of, I don't know how I forgot
I
this, but
think
anyway,
we need to thanks to BDME.
sorry. Somebody pointed out.
Yes.
That was a grand miss. Okay. No, we are just going to repeat what we have just discussed now. It is just a very little thing. We were discussing that we are going to enable this particular project, or rather a demo on a GitLab. So what we are doing is we are using the GitLab pipeline over which we have deployed few jobs or configured few jobs, Terraform jobs. What we are doing finally is we are going to provision, what? Provision a VPC. VPC is a network element over the cloud. Other than the default VPC, which we already have for a particular region like Mumbai, we are working on Mumbai. We have this IAM user, which is DevOps Internship, which we have created earlier. Okay. Besides this, we want to have our own VPC setup. I'm going to have my VPC with a particular CIDR. Okay, but I will not go into AWS Cloud and do it manually. Maybe I am not being authorized to do anything on the from the console. Okay, so what I do, I have created a pipeline on which I have put in few jobs created over the Terraform scripts. I'm going to run them automatically, one after the other, this particular jobs through these stages. The one that is marked as red is the stages, and the one that are already run as a picture, these are the jobs. Once this is run, you will see a VPC has been created. That is what I'm going to demo. Now, as we have seen that we need a runner because we are doing a self-managed GitLab runner. We are not using the software as a service GitLab I will manage services. We are not going to that because that is costly. So we want to save the cost. We have created our GitLab runner, and that runner is going to run with the executor as Docker. So we see that I would like to check whether my Docker is running in the background. Yes, my Docker is running in the background, which is active and running. Fine. So based on this Docker, which is a containerization tool, I am going to use a pipeline runner. The runner is the one utility of GitLab which will execute the jobs, but on top of the Docker as the container ID, the container D, the daemon. Okay, so this must be on. Now I will go to check my VPC. I'm going to check the VPC service of the region called Mumbai. It can be any region. Any region will have their own VPC. So I'm going to my VPC for the Mumbai region, and I find that there is a default VPC. That's fine. That is the default architecture. Okay. Keeping this in mind, I will now go to my GitLab. Okay. So see, this is your GitLab interface. It is very simple. It is not cluttered, but it has a lot of power. Okay. So while we see, you just have to, as I said, that GitLab is an instance or somewhere on the cloud. You need to just, it is absolutely free of cost. We have created our project. So many projects have been done. Okay, but I didn't have to pay a single cent to GitLab or to anyone else. I am creating a project. Okay, so this is my interface. I just have to create. I created my account. That's all. You will have to also just have to create your account. That's all. That is what is needed. That's all. You like on the cloud, you have an account. On Docker Hub, you have an account. On GitHub, you have an account. So this is same. You just have to create an account and start working. So let's say I have created I have built in everything for this. So this is a new project. So the projects can be created very easily. Going to the new project icon, and there are 4 ways that you can create a project. You can create starting from the scratch, that is a blank project, or you can use the GitLab template. For that template will help you set up the project and this configuration very easily. You can use a template, or suppose there is already a project built in and you are doing a similar sort of a project, but nevertheless to say it is not exactly the same. Then why should you do it? So you are importing a project, you are cloning it, and you are going to modify the project according, you adapt that project into your requirement, the current project requirement. That is another way. And the finally is you can directly run a project from an external repository. So the pipeline will be given by GitLab, but your repository will be given by, let's say, GitHub. So all the resources, the software resources will be there in a GitHub repository or Bitbucket repository, and you are just using the pipeline from this and running a project from the repository there. I am just going to create a blank project. It is already created for you. It is the simplest way of creating. So I can just show you. When you create a project, it will ask for the project name. You can give any project name, any combination, capital letter, small letter, doesn't matter. But whatever you do, it converts the project name into the project slug. So that slug is nothing but your project repository. As I told you, GitLab is not only a pipeline software, CI/CD pipeline software. It is also a version control tool where you can have your project repository. And not only a version control tool, it can behave as a GitHub. It can also be your project management tool like Jira. And also it can be your, you can monitor, you can secure, you can inbuild the security, and you can do a lot of things. As I told you, there is a code review. So these are the quality features that is already inbuilt. It's a big, big bonus that when you use GitLab. Anyway, let us go back to the projects. I similarly have created a new project called GitLab Terraform project. So this is my account and this is the project. So I click on this. I have already created the project for you, and very simple. On the left hand side, there is a navigation area where you have various things. So here are the pin, the issues, the merge requests. So the issues are whatever the issues that you are creating. It is like a storyboard. It's like Jira, and you can manage your project like Jira. You have activity members labels. Then also you can plan. It is also part of, it is like Jira, where you can create your issues, you can create your Kanban boards or Scrum boards, you can define your milestones. Also, you can have a wiki documentation, a repository, artifact repository. And then there is the code part, where you have the merge request, merging the various branches, the codes from various branches. You have the repository on a particular branch where you have developed or something. There are branches that you can commit your work. These are the various things that you can do. We will learn it in our main course. There is the build. Under the build, you have the pipelines, the way you create your pipelines, the jobs, the pipeline editor, whatever. You can secure, you can apply the security, all the capabilities, audit events. You can do a security configuration. And then comes the deploy. You can use GitLab for deploying your entire project. Okay. So you can define your releases. It's basically it is on an agile project. So you have sprint releases. Okay. You can do everything, all and everything inside one tool. Then there is one operate. Under this, right now, I can go, you can operate your Kubernetes cluster if you have built in the Kubernetes. We are also going to have sessions on Kubernetes. Coming 2 sessions will be on Kubernetes. Then your Terraform state. This is a very important part which has been included. So you can keep your, right now, there are no Terraform state files. We are going to build that. We are going to do that in the project. So right now it is not there, but what GitLab has done, nice thing, it was lacking in so many other tools, was that it has provided Terraform with a very safe and secured place to store the Terraform state files. And that state files are the backbone of Terraform. Okay, that is one big thing. Then you can have monitoring, you can error track, you can devise the alerts mechanism, incident, service desk. So a lot of things are there you can use. You can analyze, you can code analyze you can have value stream analytics, all the analytics, even the pipeline analytics can be done that as CI/CD pipeline analytics. Repository, like how you are storing your source codes and whether they are according to the standard one. So this is, and finally the settings. I come to the settings. Access token. I have created an access token for the project. For this project, I have given this project access token because these tokens are the part of security feature of GitLab. I have created a DevOps Internship token. We are going to use that token. Then you have the CI/CD. Now this is the CI/CD pipeline environment. Remember, we have told you that unlike Jenkins in GitLab, you simply do not have to do anything. You just use the pipeline is already set for you. Just you fine tune it with few things. Like let's say the runner. You are interested with the runner. You say, Debashish, how do I make a distinction between our self-managed runner and already the instance runners available with GitLab? This is managed runners, which we are not going to use because there is a lot of dependency. Whereas we create, and these are also costly. So I have created this runner. You can create a project runner. You click on it. And you see, I am going to create a GitLab runner on Linux. and I will be using the containerization technology of either Docker or Kubernetes. Since I do not have a Kubernetes cluster, it's fine. So either of them or both of them, because you must know that Kubernetes also uses Docker for containerization. And so I have created a runner, and that is the runner. That is the runner. So where we go, this is the runner that we have. Can you see a green light? Because it is saying the runner is online. This was made online 12 minutes back. Did I not do it? Yes, I did it. I switched on the runner, and that runner was, you see, this was the status of the runner. The runner is running, the service is running, and that has been associated or registered with our project. So this is assigned to our project. This is our self-managed runner. Now I'm coming to all the, okay. One more thing that I need to do is, I hope you are following, though I have to rush a bit, but that is okay. Variables, they're CI/CD hidden variables. These are the secret variables. I do not want to, because I'm using Terraform. Any external tool which gets into AWS or any cloud will needs an access permission, authorization permission. And through this access key, I will be allowed. So AWS CLI, through this, I was able to create. This access key is nothing but, my this DevOps internship is having an access key, the security credentials. I am putting those credentials over here. I am putting those credentials over here in the CI/CD confined or secured variable environment. AWS access key. See, I have masked it. So masking is nobody will be able to see the value. So if you go to this is masking. I can protect my value, protect my variable. So nobody can access it or remove it or tamper with it. But here I have used mask. So my access key, some value is there. I will not show you that value. Oh, it's okay. If this was a temporary user, so the user credentials are there. The AWS secret access key, the token was the project access token that we have seen earlier, and the username. The username is like, what is the account name through which you have got into your GitLab. Okay, so all these things are hidden. I will not like anybody to have an access to this. So having said, these are very minimal settings. If you have learned Jenkins, you will see how much difficult it is to set up the environment. Here it is simple. All these things are done manually. Now the main part was this. I go to my repository. I have created, see, this is my repository, GitLab, Terraform, project, DevOps, internship. Can you see a dash? Though my project is GitLab, space, Terraform, capital T, project, DevOps, internship. All these are in small letters and separated by a dash. Anyway, this is called the project slug or the repository. And under that, I have a Terraform folder where I have kept all my Terraform files. The provider file. Okay, I'm not going to do this because Terraform session is already over and we are going to learn them in our main course. Oh, this is a very interesting part. Okay, the main.tf. Very simple. And I'm just going to make it a bit large. So you can see that it is DevOps Internship VPC. What is that? This is the resource that I'm going to create, the VPC. I'm going to define the CIDR block. Anyway, that is right now everything has been built for you. I go back to my Terraform folder, and this is the variable. It's a very, very simple project. Very, very simple project. So I have defined my 10.0.0.0/16. So this is called CIDR. This is, I am building my own VPC network, and it is definitely on the AP South 1, which is my region, Mumbai region. So all these things have been defined. I will go back to my, so Terraform files have been defined. This is my main pipeline script. You can see. Okay. Sorry. Can you see this? I have defined the workflow, the variables, the stages. Now, how many stages are there? Validate, plan, apply, destroy. I'm doing some image. I'm using Terraform, so I'm using the Docker image. This is, I have taken it from the HashiCorp, which is in the Docker Hub, Docker registry. All these things are there. So an image, a Terraform entire thing, I don't have to install anything. That is the beauty of the containerization, you know, and I'm using this to do my Terraform work. Terraform validate, you know, Terraform plan, Terraform apply, and finally Terraform destroy. Okay. But these I'm doing through stages. And right now I'm putting them into manual. That means I will not allow this to run automatically because I want to have a control of it. Okay, let's see those. Everything is manual now. Manual. This section, this stage apply is also manual. And of course, the destroy has to be manual. Only when I am happy with my pipeline and the job that it just performed, I will go for destroy. So let me come back. I will go to the main thing. I will go to my build. I'm building it. I'm building my pipeline. So I clicked on pipeline. There are currently no pipelines. Yeah, I have not yet executed my pipeline. I have not yet executed my pipeline. I've just done everything. Okay. Let me run the pipeline. So running the pipeline. See, I have the pipeline script, that GitLab ci.yaml. Is the pipeline running? There are there are 4 jobs. There are 4 jobs: job validate, job plan, job apply, job destroy. They are not yet. They are sequenced one after the other. First, it will run the validate, the plan, the apply, the destroy. I have also built a dependency that I cannot start to run plan unless and until validate job work. So there is a dependency. I cannot start applying unless this stage is completed. And of course, I cannot do destroy unless all these 3 are done. So this is manual. If I go, you see, validate, that job is a manual job. What I do? Okay. I could have done it automatically. There will be a trigger whenever the developer or you put in some changes into the pipeline will be triggered. Just to show you, I have not done. What I do, I validate. Before that, I go over here. You see, there is nothing. No, I have not yet created this thing. I will go and I've clicked it, manually clicked it, and I'm going to run the job. I'm showing it with each job being run manually. First time. See, it is running the GitLab runner, the runner which has been registered with that, which is running in the background for that particular instance. And you see, it is giving you the Terraform version, and it is initializing the backend. It is getting that plugins for Terraform all downloaded, and the plugins for AWS, because I'm going to see. Can you see the mask? You cannot find out where this particular thing has happened, this particular log file or plugins folder. You cannot find it out because they are secured. You can never go to this particular. So I can see that it has passed. So the validate has passed. I can go to the pipeline to see this is a pipeline number. I click on it and I can I can see a holistic view. So out of this pipeline of 4 jobs, the first job has passed, validated. Now I will manually run the plan. I know you might have some questions. Please park those questions. We will attend it after we have completed. So it is running the plan job. In the stage, this is the stage, plan stage. I have given the stage and the job name the same, such that it is easier for you to understand. It is running the plan. So the job succeeded and the plan is to add one resource, and that resource is nothing but the VPC by the name DevOps Internship VPC. I will not go into the details of it, but yeah, and you can see that CIDR 10.0.0 according to your scripts has been done. So it has successfully done. So I will go back to my pipeline to see, and I find that yes, the second job after validate has also passed. Now finally, up to this stage, now I will suddenly remember that, oh, whether my state has been created. Without a state being created, I should this apply should all get from whatever the state plan is. So let me go and check what happened to the Terraform state. Can you see earlier the state file was empty. Now it has created a state file somewhere in the internet. It is called in the HTTP. It was updated 1 minute back. So this was just created from the Terraform states and the job. Fine. So we go back to our pipeline. And you will see we have already done the stage validate plan. I will click on this. Up to this stage, it is passed. I click on this. I will go to apply. Now, till this point, there was no VPC, no new VPC created. My mouse is doing some problem. Anyway. So I'm running this job of apply. So I'm applying my blueprint, which is the plan, such that it is physically now creating that particular resource over AWS. So this is the log file it is generating behind the scene. So, and it is a very, very nice way to see what is happening in the background. Can you see it is preparing the Docker executor? So the executor is Docker, and you can rest assured you have Docker running with the runner in the background. So the job succeeded.
Here, one thing I would like to tell that if anyone has any question, feel free to raise your hand, and we'll definitely attend those questions
Sure.
because am I right, Mr. Devash?
Yes, yes, yes. Why not? That is what I said.
Yeah.
And we do not have a lot of scope to explain in details, but that will be done in our main, your course. Okay.
Yes.
Just for the purpose of demo, I am just saying that can you see that this AWS VPC by the name demo VPC is getting created, and it was created. It took only 1 second to create this. So a VPC has been created. You should not believe me. Rather, I should verify it. So let us go back to the VPC, that console, and I will refresh it. Suddenly you see that there is one additional VPC by the name DevOps Internship VPC has been created just now. And can you see the CIDR? The default CIDR is definitely different from what your company CIDR wants to build. And it is not your default VPC. This is the one that you have customized, you have built yourself. And who has built this? Our pipeline jobs through Terraform. So I'm very happy that I can create it without doing anything manual over here. So let me go back. Let me go back to my GitLab. And I can go back to my pipeline. And I have a holistic view. So I'm very happy. My validate worked, my plan worked, my apply worked. So if I'm happy and I verified that my VPC has been created, okay, now my management says, okay, Devashish, you have done a very good job. It was a proof of concept that whether you are quite good at your work. So we are very happy. Management is very happy. So fine, you destroy because it is not. There is no point. It does not make any sense to keep the resource over running on the AWS because company has to pay for the resource getting run. So I decided, okay, management decided that please destroy the resource. So I already have the script. What I do, I just run the job. So what it is doing, it is going to use the Terraform destroy script to whatever the state file will say that, okay, there was one resource created and that was a VPC, please remove it. So it is refreshing the state and it is going to, because it is destroy, it has destroying the ID. This ID has been destroyed. Now this resource has been destroyed. It not even took 1 second. It was in nanoseconds that it was very fast. So I can go to my pipeline and see that the pipeline is entirely successful. All 4 jobs have run correctly. So I will let me go over there. I will again refresh it. What is the result when I refresh it? Can anybody tell me what will happen when I refresh it? Will I see both of them or I will see one of them? Surely I will see only one, the default one, because this was created out of my pipeline and this was destroyed out of my pipeline. So I will not see this. Let's see. Yeah, that's true. Now the other part is what we have done was I was doing everything very, I was having a look at it. I was doing everything, but finally, when I deploy it into production, so I cannot do manually all these things. I should not run it manually. What I do, I will go to my code, go to my repository. I will do a particular change. to make it fully automated. So I am doing some change over here. I will edit to my pipeline editor. Right now, the only change that I'm going to do is to take out the manual part. So I'm making it entirely automatic. So I'm doing some change. This is a change on the pipeline. I'm not going to make the destroy job as automatic because I want to stop there. After I have created the resource, I want to check it. And then if I'm happy, then I will destroy it. So this is my change. And remember, if I have designed my pipeline in such a way that there is an automatic pipeline, if there is some activity, some change over onto that pipeline, immediately the pipeline will be triggered. And that is one change I have done. So I will commit the changes. And you see it is validating the pipeline. Pipeline syntax is correct. And it is checking the pipeline status. So it is triggering the pipeline. It has triggered the pipeline. So I can view the pipeline. I go over there, view the pipeline. Can you see, did I click on this? No, but it is running. See, the validate is running automatically. You can go and check the log. You can click on this and check the log. And I will not do anything automatically. You will see after validate, automatically the next in the pipeline, which is the plan, will be executed. So job succeeded. Now you will see that it will be automatically changed over to you go there. You see the plan. I did not do anything clicking. I did not do it manually. It automatically started once it was correctly executed. The plan started. So let me be there. I'm not going to go to the log. You can see that the thing turned into a right sign. So the plan passed. Now it has automatically switched over to apply. It is running apply. Apply will take a bit of time because it is creating a resource. Yeah, it is done. So out of 4 jobs, 3 jobs have successfully run, and it's very important. This is the approval stage. You know, I can switch over to destroy only once my management or the client approves. So let me go and check whether the script has been done or the resource has been created. So I will refresh it. Yes, DevOps Internship VPC has been created again automatically. And I'm happy now. So what I will do? I will go over here. I will click on the destroy. That this is manual activity because destroy is very, very dangerous thing. So you must destroy once you are confirmed that everything is working. So the destroy job is running. I can go to my pipeline. I will see whenever the job. So it is destroy. Running. It has done. So if I can go over there. if you go over there and you just say refresh it, the resource is gone. This was the entire demo that I was supposed to do. So we switch over to Docker. But before that, I would like to take your, questions if there are any. Is that right? I'm sure many of you
Yeah,
could not follow.
I think we
But
have
that,
done a couple of last week 2 hours, 2.5 hours. Today is 30 minutes. So we assume that those students are following
yeah.
seriously,
Yes.
definitely, and they are trying with the hands-on. Try to follow the steps. We assume it is very common. They will stumble some of the issues. We are happy to resolve those issues. One of the Pradeep have asked one question that can you do the same pipeline in GitHub? No,
No.
cannot.
That is the difference these are the differences that we have discussed in our previous session.
So GitHub is only the repository, and GitLab is it is a complete DevOps pipelines where you can create or manage any of your DevOps CI/CD pipeline, including repository in GitLab platform.
So starting from your it can execute the entire DevOps life cycle, not only a pipeline, starting from planning to deployment, monitoring, everything through one tool. I think you go through the recording again, yesterday's or the previous session's recording. You will get to know a bit of it. Yeah, I'm very sure it is not you over a session. It is not able to be covered, but that is why we need to go through a detailed study. So with your, permission, because we are running out of time, we have to cover Docker. And today, I similarly believe that I will not be able to give a Docker demo, but at least we can cover the theoretical aspects of Docker. So we will take over that demo to the next session before we start Kubernetes. Is that okay? And because Docker and Kubernetes are very much related. Yeah.
I think we can complete the Docker at least 50% today, the theoretical part. The rest 50% we can start from the next weekend, because it is already 1 hour is completed.
Yes, already 1 hour.
Yeah. So guys, please feel free to unmute yourself and ask question. If you want to share your GitLab portal where you are doing practices and you are stuck with some issues, share your screen with us and we can try. Will guide you. It should be an interactive session. So no question is bad question, and this is like a awareness and kind of training program. So don't feel shy to ask question.
Yeah, that's very important. See, this is a discussion only. It's an awareness program. So we should be aware of what we are learning and how much we can take forward. It is basically to churn up your interest in this subject, because unless and until you learn DevOps, it is very difficult for you. I'm not saying very difficult. It can be difficult for you to scale up, because there are so many related things, but your basic knowledge of DevOps should be very good. We are going to take up DevSecOps, cybersecurity, then SREs, site reliability engineering. But they will have your basics of DevOps very correct. You should be very good in your DevOps skills. Okay. So if you do not have any questions, and frankly speaking, we are not in a hurry. So if it is needed that we need to extend one more session, we can do that. If for your convenience, for your benefit, if we need to extend, say after 2 weeks, we are going to, that program 2 is going to end with 2 sessions of Kubernetes. But if needed, we can have one more session. But I'm not saying it is absolutely needed at this stage. I will try to cover within that schedule.
I think Bidemi is trying to say something.
Yeah.
I'm just trying to look at now I was just looking at you said destroy. Now on the job, right? Once you have provisioned your instances with the Terraform, but you said once the management seen it, and then you can destroy it, even though, in some organizations, they say it's not always good to destroy, because if you do that, you probably would have destroyed something else,
Exactly.
So I'm just trying to figure out if, that's always the case. You provision it, then afterwards you destroy it, or you got to keep it in an organization. We know we're doing it here just for practice, but in the real world, do you have
so? Yeah, very good question. Actually, fantastic question. So what you do is these are you make the destroy part a separate module. You automate the rest of the pipeline, but for the destroy you go through an approval process. So, see, destroy means not only destroying your resources. Maybe there could be some cleanup activity, some cache cleanup, something cleanup. So that is, once you have automated the rest of the pipeline, you take an approval process. There is an approval process, and after that, if there is, it can be a day-to-day house cleaning job. So in that case, you put it into the automated pipeline, if at all it is needed. So that's why you keep that section under manual supervision. That means you must not take out the manual thing. You must not automate it. You keep it separately. If they want, okay, Bidemi, you clear up or you destroy this particular resource, you just pick up that code snippet and automate it and execute it.
So the manual aspect is still kept intact, so that in case of it,
yes,
yes. So you all need to just go back and automate it again for whatever program.
You saw in my second run, I put the validate, plan, and your what is that? Another thing, apply in the automated pipeline. And whereas I kept the destroy in a manual event, as a manual event. So I should not be, I create and automatically delete that. There is no purpose. So I keep
so
it.
you do not automate the destroy aspect. You keep it manual. So you have to control that.
Yeah, I don't like to control. Okay. There can be so many aspects of the pipeline where you want your control. You should not automate it. Okay. Automation means not only you automate the things that you regularly keep on changing. Suppose a developer is putting some change in its code. So that portion you automate it, because you do not need to manually, because in the mid of the night, the developer from India may have put in some change into the pipeline. Okay. So are you there to manually execute it? No. Your pipeline will take care of it. The automatic build will happen. Automatically, your packaging will happen, and the release will happen. So it will go to the testing automatically. Followed. So a developer in the mid of the night, somewhere in Japan, has put in some code, and that code needs to be available to the testing team. So I have built a pipeline, automatic pipeline, such that whenever somebody makes a change, That change will trigger the pipeline, and the pipeline will take the job, build it, package it, and release it for testing.
Perfect. That's awesome. Thank you.
I think, correct me if I'm wrong, Mr. Devashish, this destroy part is also secured with access control. So with certain access level only, it can be, and in the hierarchy, only they can destroy the pipeline.
Oh,
anyone can.
The destroy part is only available with the admin.
Yes.
Like I have shown you the security credentials. Okay. Who is the developers or the DevOps engineers generally won't configure them. Yeah, if you are an admin as well, but generally the admin or the project lead will keep all those secret informations privately. That means whenever, see, in my, let me go back. I will again come to this part. So when somebody like an admin is this portion, the settings portion is for because if I am a developer and I do not have an ownership to do all these things, my role does not permit. So I will not get this option at all when I log into my project. With my role, the settings option is not enabled. So when an admin for that particular pipeline or whatever, the admin guy having that role will go into this project, then only that person will be having an access to these settings. So it is all very controlled. The access controls are very much in, because that person can go to CI/CD. That person can go and destroy the runner if he wants that this runner should be removed. So that needs some administrative privilege. An ordinary person or a user only will not be able to do all those things. These are the security measures followed. So I will not be able to also go and check my I can collapse it. And I can go to my variables and expand it. You see? So if I go and try to delete it, what happens? Then the Terraform will not be able to access AWS. So these are the things which can be very dangerous for anyone to do anything. So those are not exposed. Did we answer that question? It's a very, very secured one. The access control level is very stringent.
Yeah, you did.
But the main purpose is someone is doing some change into the pipeline, and the organization has taken a step because they are in a very advanced stage of DevOps implementation. They say that I should be having a pipeline wherever, from anywhere, any corner of the world, somebody putting something, some change. Those needs to be validated. First of all, the code check will be there. Maybe a SonarQube tool will be there in between the repository and the pipeline. So when the pipeline is triggered, the first job is to validate the code through SonarQube tool. That will done. So whether the quality of the code will be checked first. If the quality passes, there is a threshold that if it passes that threshold, then it will go to the next stage of executing the pipeline, and the job will start running automatically. And then it will be coming to the packaging, releasing, the building, packaging, releasing, and it will go to the testers. It will either be deployed to the pre-production environment for the users or the customers to test it, or maybe to the test environment for the testing team to test it with Selenium or a JUnit. But when in the morning the testing team comes, testing team will start their work, irrespective of getting back to know what happened yesterday night. Whatever, they are going to get some new code, some new build to be tested today. So that's how it is very, very synchronized. Could you understand the power of this tool and how it is? The best is how you use it, because many people learn few things, but they have to understand the practical utility of why we are going to, how we are going to use it. And when we do in our main course capstone project, you will come to know how many tools it is. I have used only for the demo purpose one tool, and that is Terraform, and that is also a very simple job to create a VPC. Okay, but in our capstone project, in our real life, when you work in an industry or in a company, you will be given much more complicated work. So in a capstone project, in our course, we will see how complicated, how many, not complicated, I will say, how intricate, so many tools are working together as if it's a well-oiled engine, and how solid, how well that pipeline has been designed. Okay.
Here, I would like to add one of our very normal activities. Now, in our main courses, we have in our previous or last 30 batches, plenty students. They are not at all IT. They are not at all from IT background. They are from uh, accounting or hospitality or teaching background. Now, when they have completed our training, and after completions of the training, when they are in the process of job hunting, the very one question is very common. You will find from the interviewer that tell me about your present or last project. So when you are facing this kind of question, that means you have to describe end to end the architectural flow and what will be your what was your day to day activity on that particular flow. You need to mention, right? Now, in our capstone project, we design in such a way that, as Mr. Devashish mentioned, with this only the GitLab tool, you need to connect, integrate all with the other tools. And when the students describe about only their capstone project, that how they have integrated GitLab with AWS, with Terraform, with Kubernetes and Docker, they are actually giving a holistic overview like a real DevOps engineer who have worked on 1.5 or 2 years in DevOps field. And by that kind of experience, they have successfully secured very good six-figure job in DevOps industry. Because you can get everything, but only one thing you cannot buy it, that is the experience, real hands-on experience. Until unless you are doing the thing with your own hands, you cannot mimic, right? Now, that's the thing interviewer are looking that, okay, you have plenty certification, that's fine. But what was your previous role? And what was your day-to-day days activities in DevOps field? In that scenario, you have to tell them that the project roadmap, project your day-to-day activities, and project the scope. This capstone project of ours will fulfill all of those points, right, Mr. Devashish? Would you like
Exactly.
to add something?
No, you have added. I mean, that is, unless and until somebody experiences it, what it is actually, it will be very difficult to make it clear, So there are so many tools. They are working together in a tandem. Okay, and finally giving a very versatile result. It is quite a thing to experience.
And then, and the interviewer will definitely ask this question. And when interviewer will ask you in interview panel that tell me something about yourself, don't tell them about your hobbies or your degrees or your certifications. They strictly
correct.
want to know about your project work.
Basically, they want, when you say something about yourself, it is nothing but they are asking to describe the project that you have done, the projects you have done.
because in US, Canada, and European unions, the work culture is that they don't bother about your previous work, like your degrees or your qualifications. They need to know, and it is very crucial for them to understand that are you capable enough to resolve their day-to-day activities or not. And for that, you need to showcase your skill set or your hands-on skill set specifically. So keep it in mind, those students who have already joined and completed our classes, the main training, Kickstart project is the key for that success. Because on that Kickstart project, you are actually working with all of the DevOps tools, including Linux, AWS, Git, Ansible, Terraform. Everything is included in a single project, which is called which in our Kickstart project. So that is very, very important. I think anyone have any other question?
So
If not, then
that's good.
we can
No,
move.
no problem.
We can move to Docker.
Yeah, we can move to Docker. Yes.
Maybe Docker
So
first 20% or 30%, because otherwise those students who is unable to join today, they if they join next weekend, they will feel a little, if we start from the hands-on, they'll feel little,
no, that's
they lose
fine.
the.
It's fine. What I will do, I will divide it in two sections. So theory 1, theory 2, and demo. So theory 2 and demo will be on the the coming weekend. Is that fine?
Yeah,
See, I
that's
will
fine.
not leave this topic without covering the entire plan that we have scheduled for
Yes,
each of the topics. Okay.
right.
It may end up that I have to take up one more session. That's okay.
Yes. Guys, please stop us or raise your hands if you have any question, even the training related, Docker related, topic related, or job hunting related. We are will happy to help you out.
Hello, sir.
Yeah, Pradeep.
So
Yeah, sir. What kind of topic we will cover in upcoming days? Like what kind of tools we will cover? I want to ask you.
Come again?
What kind of tools we will cover in upcoming days? I want to ask you.
okay.
So today is yeah.
Yeah.
Devesh.
Yeah. Menon, please.
Yeah. So today is our I think day 7 session. We have already covered Linux, AWS, Ansible, Terraform, and today is GitLab second days. In next weekend, we are going to cover Docker, and next to next, we are going to cover Kubernetes, and we need 2 weekends consecutively, like 4 to 5 hours, to give a brief demonstration about Kubernetes, because Kubernetes itself a very huge ocean, and it is a very well trained in job market. Okay, every organizations, they are not using Kubernetes in their infrastructure, but still they are highly interested to hire somebody who knows the Kubernetes. So
Because in our
we
recent survey with the market expert or industry expert, we have found out that our students going for interviews are also facing Kubernetes questions. A lot of them. Initially, earlier, say even 1 year back, what we observed that they were just restricting their questions with the cloud, the Ansibles, the Terraforms, the Git, but they were and Docker, but they were not asking particularly about Kubernetes. But recently, almost 6 months now, they are into asking a lot of questions on Kubernetes. So what we thought is Kubernetes part we have to include in our main course as well. So we have done that from the last 2 batches.
Okay. And so what kind of project like we will cover in this training or internship program?
What is the project? That is what
Yeah.
Mr. Menon was describing you about the capstone project. Capstone is like a real life project, you know. A
Okay.
capstone project is, if you can search for the definition in Google about what is capstone, CAPSTONE. Capstone project is a real life project. That means something which is very complicated, something which is very realistic, and something which can, if you can complete a capstone project like that, you are getting an experience, sort of, you can talk about it in your interview, and they give a
Yeah.
lot of value if you have done such a project,
Yes. Understood.
because
Now
it
here,
covers end to end. It covers end to
now
end.
let me give you the brief idea why the capstone project is important. Because our main job market is the biggest job market is US job market. Now in US there is a tendency for the interviewer, they are not interested about your educational background and your they don't want to know about your certification and your theoretical knowledge. Most of the question you will face are real scenario based question. So
Yeah, sir, that is
and for
right.
to answer that those kind of question, you need to actually have a hands-on experience. Now those students are coming from different domain or different background or very freshers. Now in USA there is a very less like I think maybe one or two company they have like internship program, like paid or intern program. Most of the company they want to hire experienced people. Now freshers who just want to join as a DevOps engineer, they will face the same kind of like a real hands-on scenario-based question. So how to answer? To resolve this issue or fill this gap, we have designed our capstone project. When they will resolve and practice with this capstone project, they will actually deal with all of the DevOps tools in very depth, in-depth level. So when they will explain the same experience with the interviewer will have an idea that this fellow has a genuine hands-on experience on this particular tools or tool sets. And that become our very success story of our students, previous students. But this capstone project itself like a 40, 50 hours to complete, you need to complete, apart from the training. And that is beyond our scope with this free internship program.
Yes, sir. Understood.
Understand? Okay.
Thank you.
Any other question?
No, sir, not now.
Okay.
Okay, so with your permission, let us move ahead. Let's go
Before that,
yeah.
quick note, our next DevOps training course, not internship program, training course is going to start the next Friday. We thought we are going to start this Friday, but our previous classes extended for a couple of days. That's the reason we have to delay our session, because normally we have to extend our normal classes to resolve all of the students' queries and questions and make
Yeah,
them real DevOps engineer. So our next training for 75 hours live and 50 hours project work training is going to start next Friday, 7:30 p.m. Central Time, which is near about 6:30 a.m. IST time. This is like we can take only 6 students in one batch, because 80% of the training is hands-on. To make and maintain the integrity of the course, we have a threshold limit of 6 students, 6 new students, and 4 revised students we can take in one single batch. So that batch will be our US evening batch, and it will go for next 6 weeks. So those people are interested, don't wait to register yourself, and because only 6 new students can register. Once that students register is complete, the link will be invalid. If you have any doubts, feel free to ping us or ping Mr. Debashis as well. Okay, I think I have done the this announcement.
Yeah.
So yeah, Mr.
Okay. So let us go to a very interesting topic called Docker. Are you being able to see the screen? If anyone can respond.
Yes, sir. Yes.
Great. So let us come to this topic, which is a very important topic in our entire DevOps journey. Okay, so which is called Docker. Let us start without much ado. Let's understand. So before going to Docker, to understand what the Docker is, a particularly Docker engine, something which it's a tool. But before that, we have to know about the concept of a container. Docker is like a ship. A ship is carrying a cargo ship. Is carrying, you can see it is carrying a huge containers, right? From one port to the other port. Correct? So you may be wondering why we are learning about container and what does that ship has to do in our DevOps journey. That is the important question, and we are going to address that. So a container is a standard unit of software that packages up code and all its dependencies, so the application runs quickly and reliably from one computing environment to another. You will not understand this definition right now. I'm not going to try to make you understand this definition right now, but just because it is a software tool, container is a software package. Okay, it has everything within the container. Container, you can say a bucket or a huge place where you have all the environment set up for an application which can run within that environment. That environment is called container. So container images become, so I have highlighted images and container because they cannot exist. One cannot exist without the other, as if they are, made for each other. A container is made to hold the images, and images are there to run inside a container. What is an image then? The image is the application that we are trying to run within that container. If the image is a static image, some static application, that will be considered as a static image unless and until you put that into a container. The image is nothing but a dumb thing. It becomes intelligent and it starts running inside a container. So you can say create an analogy between the container of a ship carrying some important item. Let's say it is carrying steel, it is carrying your cement, it is carrying rice, huge amount of rice to some port from one country to the other country. So that container carrying rice will be unloaded into, so that port is one port is called platform, a software platform or a platform, an infrastructure, and it is carrying to another platform, which is also an infrastructure. You just don't have to do anything. You just have to download, or rather offload the container, and therefore because the container has the environment within it, you need some medium, and Docker is that medium to execute that container. So The images become containers when they run on Docker engine. Available for both Linux and Windows based application. And not only Linux, it is available for nowadays, it is also available with Mac. Okay. Containerized softwares will always run the same regardless of the infrastructure, whether you are running it on Linux or Windows or Mac, doesn't matter. Because as we said, your application which is inside a container is very safe. Like as if you are putting up you are taking up a house from California and placing it in New York without any change. The house remains the same. So if that can be done, how much effort is saved? Let us go to the next screen. So I have an image. I like to always explain through the image because this image is going to speak about 1,000 words. I cannot keep on telling about the statements and definitions and this thing. But once you see a picture like this, most of your definitions gets very clear. What is happening? This is some, let's say this is a place. This is a Docker engine within which you have, or let's say this is a system. This is a Linux environment. And you have Docker containers. Docker containers are, you can see this is like a container, huge container. Like in India, you have seen the cargo trains, and they are carrying a huge containers. They run on the railway tracks, and you can see within few seconds they pass from your vision. They are getting carried from one station to the other station. Similarly, here also, let's say this is a container. This container is having thin writable layers, whatever it is. So container is an environment where you can made up of, so the Docker is made up of layers, a Docker image, sorry. Image is made up of layers, layer 1, layer 2, layer 3. Each of the layers is a software layer because your image is nothing but your application. So maybe this is the operating system, a very lightweight operating system. On top of it, there is a web layer. Let's say this is Nginx or Apache Tomcat, the web layer. Then you have installed Java. This is the Java application. And on top of you have your source code deployed. Source code maybe it's a Java Spring Boot application, the application that you have written. So the entire thing is one big image, but is very lightweight because you do not have the OS at all. But you only have the, what is that? You think this is a container, big container, okay? The lowest layer is the boot file system on which the container will start running. There should be, see, container is after all a software package. A software package. A package can only be deployed, or it can start with some. This is the C groups or namespace device mappers. Or better to say, this is an environment on which the container will start or boot. Because there is no real OS. You have the OS kernel only. Maybe this is an Ubuntu kernel, or maybe this is a Windows kernel, or maybe this is a Mac kernel, or Red Hat Linux kernel, Ubuntu Linux kernel, only the kernel. And this kernel will again have a top layer, which is the C group. C group will manage the resources. So what is the function of a kernel of an operating system? It will manage all your resources, whether it's a printer or a monitor or your keyboard or some devices, video devices, some audio players, whatever it is. It will manage those external resources. And what about namespace? Namespace isolate and secure them. So all the resources have their own spaces to work. And who will ensure that? That is the namespace. So basically, I'm not going to the details of that, but just remember this is the environment of a container on which your image is going to run. So on top of it, maybe you have a base image of Ubuntu, base image of an Ubuntu software. Ubuntu is a Linux. Then you can add one more image, then you can add one more image, and then this is, you can keep on adding layer after layer. Okay, so a container is a space where you keep your images layer after the layer. And therefore, when you say that I have a container, that means you have some image which is like it is some application or your application which can run inside the container. Why do we need this? The C groups play a role in containerization solutions like Docker and Kubernetes. You don't need to worry about all those things right now, but just say that the container has an environment inbuilt which will help your image to run. You do not need to create your environment separately. You just have a container. It is like a plug and play software. You take it out and plug it in somewhere else, into some other platform. That's all. It starts running.
Sorry, I have a question. So this writable container block, what does it represent in the image on the left?
This one.
This writable container block, is it representing the 10 writable layer or the layers?
No. This is one container. Container 1, container 2, container 3. So this container will, generally the thumb rule is one container should have only one image. Image means this is a total image. The image can have different layers. That's fine, but you should not have more than one image inside one container. You can have 100 containers. That means you can have 100 images. So this one container. These containers have their own, each of these containers will have their own ports. And when we learn Kubernetes, these containers will be having one more abstraction layer called pods. And the pods will have their own IP address. We will not worry about that. But as your question says, what I can understand from your question is you are trying to understand whether these containers will provide you with like a compartment. It has many compartments, many layers, so you can fit in as many layers you want of the image. You can have the base layer, then on top of that you can install one more layer of software and one more. Let's say this is the OS, very lightweight OS called Ubuntu or Windows. On top of this, you installed Apache web server. On top of that, you installed Java. And on top of that, you installed some Java application or jar file. So you basically wanted to execute your application. So you put that application with these layers into this container, because unless and until you put this image having all these layers into a container, you will not be able to execute your image or your application. Did I answer your question?
Okay, so the image on the right, the writable container, depicts the layering.
Exactly.
The bottom of that one, and that whole block is put in the thin writable layer portion.
Yes. This is a one container, so I can say that this and this is the same, or this and this is the same. This is the this is the outer thing that you are seeing. You cannot see what is inside. So what you see, this one is what you see inside. This is just a diagram. Followed.
Okay, thank
you.
So
what is inside? Inside of the container, there is an environment. On top of the environment, you have the base image, and you keep on adding image after image. And this This container is not having any finite size. The size will depend on what are the images that you have installed or deployed onto that container. So it's a dynamic sort of an environment. It can keep on scaling up or scaling down. A very interesting concept, and we will explore further. And as Mr. Menon has given me the leverage to carry on this discussion in the next session as well, so I'm very happy. I can go into details of it. Okay. Because I had a pressure that I have to complete all these things within this session. No. So I thank Mr. Menon for that. You see? Now, the second part of this is, then you will say, what is a Docker image and a Docker container? Yeah, they are two different objects. They are the two different objects in the Docker lifecycle or ecosystem, you can say. One is the Docker image and the other one is the container. They are two different objects, but what I'm saying is a Docker image cannot exist without a container, and a container has no meaning without an image. You cannot have a container, a empty container. You cannot, because think of a ship. Will the ship run from one port to the other port? Can the ship depart from a port without with containers having nothing? That is not practical. Why should you? Because it is a very costly transportation. You cannot send just a container. Container is just a layer, just a package. If you are presenting someone with something, some gift, you cannot present something with just the box without. So the person receiving that presentation unlocks or unpackages it and finds nothing inside. Is that good experience? No. So similarly, I cannot have a container without an image. It does not have any meaning. So once I put in an image inside a container, let's say I can have the same image. Let's say I have this Java application, which is created as an image, and I have stored into my Docker repository. Okay, or in my private in the account of my repository of the Docker repository, and this I'm putting it inside this container. I can have the same image put into the various containers, multiple containers. So I can have this Java application put into this container, and this container. So the size is 1 GB. So I'm putting this. What is the container size? The container size will be a bit more than 1 GB because you have this layer. This is, if I'm saying 1 GB, then this is, let's say 300 MB or 30 MB. So 1.03 GB. A bit more because the environment, the container will have its own environment. So you put it. Okay, you put it over there. So this container becomes 1 GB size. And all of these containers are having the same image. That's also possible. So you say you are coming to a very important term called replication. So this container is a replica of this container. This container is a replica of this. So if this container goes down, at least you have this container and this container. If these two containers go down, so the same application is running on the third container. And it is by law, natural law, that the same thing cannot happen at the same time. 3 containers cannot go down at the same time. Okay, or whatever. We will come to the concept of Kubernetes afterwards. You may please ask the questions if you think so. I have enough time. I've been given permission for the next session as well to continue the discussion. So don't hesitate. Please ask questions because that is very important for the success of this. We are trying to give you the best from this, the program. Now you can ask me, Debashish, why do we need containerization? What is the big deal in it? I will say yes. Then we have to delve into a bit of history, what happened earlier. First thing that came to revolutionize the particular application environment or IT environment, software environment or software application is virtualization. Otherwise, earlier, before virtualization, it was a bare metal. A big machine used to be there, where it's like a big elephant. It is a very costly proposition. It was not very efficient. You know, when you have a bare metal in one big machine, you cannot port in multiple applications. So it's a big IBM mainframe. It's a huge database running DB2, on which you are running only one application. Is that good? You are spending millions of dollars onto that particular machine and to that software or operating system, database, and one application you are running. However robust it is, but it is, see, today's competitive world is like it is microservices. The more and more you can build up your environment with microservices, you are the gainer, because today is a mixed hybrid world where you are not very happy with one product for long. So you can use that platform today with a Java application running, that's okay. But after maybe 1 month, there is a requirement of a Python application. So will I keep on expanding my infrastructure? The question is no. The answer is no, sorry. Because I cannot keep on capital investment, CapEx. And with the CapEx comes the OpEx, operational cost, because they are hand to hand. So the more investment I do in capital investment, the more is also the investment on my day-to-day operations. It is an exponential curve. It grows on without your control. So those things are very resource hungry, and so therefore there is a very capital hungry. You have to spend a lot of money to stabilize the system because it's a big system. But that big system, the output, the throughput is very less. Yeah, they were very good for, you know, applications which are real-time applications like the telecom applications. They have to run, 24/7, all the 365 days without a single downtime, and huge number of CDRs hitting to that system. CDRs means call data records. In one second, there can be few millions of calls. Those sort of mission critical systems are very good, but that too is very, very costly as an overhead. So we came to virtualization. The next jump from there came to virtualization. Why don't we think that we have a big server? Fine. So why don't we partition it? We put on a hypervisor. This hypervisor coming from different houses, big houses like Microsoft, Oracle. They came up with a solution called, okay, I will have the same machine. I will have the same host operating system, big operating system like Linux or something. And on top of it, I put in a layer of hypervisor. So what will it do? It will virtualize as if partitioning the entire, see, one big system is now partitioned into 3 systems with the full version of OS, guest OS. Yeah, but now you have a Java application, you have a Python application, you have a .NET application, Microsoft application. Earlier, with the entire big infrastructure, you could only have the one single application, either Java application or Python application, and that too also the porting of it, changing of it is quite difficult. But now at least you have you have utilized your infrastructure a bit better. You have made it one machine, 3 machines into one. So you are running 3 applications in one machine, one bare metal, and that is called virtualization. So virtualization is the process of running multiple virtual systems or resources on top of a single physical machine. That is one jump. You see, I have jumped. I made a quantum jump from what we used to have and what we are having now. We are better in a good position to utilize the same old machine with a lot of wasted resources. Now we are trying to optimize the resources by partitioning it virtually. These resources could be a storage device, a network, or even an operating system. So you can virtualize the operating system. You can virtualize your network. You can virtualize your storage device. So all of these applications are having the part of the storage device. Earlier, only one application was using the entire storage device and was not being able to share. So if the storage device of 1 petabyte or 1 terabyte, it was only using 20% of it. So rest 80% was left unused. That is not good. But now at least you are using 30%, 30%, 30%, at least 90% of your 1 terabyte, 90 GB, 900 GB. Yeah, 900 GB was being used out of 1 terabyte. So that is a good way. Now we come to containerization. Can you see that this application is having the full OS? This application is full OS. So I can say this application is good. I am having, instead of one application, with the help of hypervisor virtualization, I am having 3 applications running on the same machine. But these applications are heavily built because you have to have the full version of the OS. Now, somebody thought that this is okay for the time being, but in future, I need something else. So what they did, they had the same hardware, they had the same operating system, but they installed a container engine. Instead of hypervisor, we have a container engine. So now that engine, what the beauty of that engine is that, can you see the OS anymore? No. Every of this application, this is called container. One container, one application. Another container, one application. You can have hundreds of applications in the same old machine. Why? Because there is only, as I told you, the previous, this is the one. Okay, the C groups and namespace, that is the environment. So this is the environment. You need only the binaries and the libraries of the application layer of the OS. See, an operating system has 2 layers. What are the 2 layers? Can anybody tell me? Let's say Windows operating system, or better to discuss about Linux. The Linux will have 2 layers. What are they? An operating system, like a big operating system of Linux, will have 2 layers. The first layer is the application layer. The shell, you can say the shell. Okay. And the inner layer, another layer inside of it is called the kernel. Here in this guest OS, you have both the application layer as well as the kernel. So it becomes too heavy. Okay, here you are seeing that the operating system is this one, that is part of the entire big machine or the infrastructure. But this, I do not have to have another operating system over here. I will just have the binaries and the libraries of the application layer, and I will use the kernel from the operating system. That's all. Why do I need to have another kernel over here, like the virtualization? So what they did is just extracted. They had this container engine can abstract a layer of application layer into this environment. That is the C groups and the namespaces. Okay. And this is, they have built the environment, and on top of it, you build your image. So this is one container with the environment and the images, the layers of the images that you have built in. Can you believe if the size of this application is 1 GB or 2 GB, the same application, when you use the container as a containerized, can you believe what can be the size? Can you have a guesswork? Let's say this application, same Java application using the guest OS is 1 GB in size. The same Java application with this containerization technology, what is the guess for you? What could be the size? Unbelievable. It will be around 30 MB. Can you compare 30 MB with 1 GB? Almost impossible. So if this is a 3 GB hardware, how many applications of 1 GB can be accommodated into this infrastructure? Only 3. Now, the same 3 GB architecture or system, how many applications of 30 MB can you accommodate? 100. Isn't it? You can accommodate 100 applications in vis-a-vis only 3 applications. So which one will I go for? Will I go for virtualization or go for containerization? Because remember, nowadays you are having the containerization, I mean the microservices. The world is moving from monolithic to microservices. We are having a slide over that. So containerization is the packaging of software code with just the operating system libraries, only the libraries, which is the application layer of the operating system, and dependencies that are required to run the code. So there will be some binaries and libraries of the application layer with dependencies that will be helping these images to run inside a container, to create a single lightweight executable called a container. So this is container 1, 2, 3, and there can be hundreds of containers that runs consistently on the infrastructure. You pick up this container and put it anywhere in any platform, it will start running. You do not have to set up an environment for that. Fantastic. This has actually revolutionized the entire thinking process. There is a paradigm shift from what you thought was a great achievement. Now you have another one. And this has really, it's a boom that came. That's why you have this Kubernetes, this large orchestration of microservices managed. So, and whom do I credit this? This guy, this virtualization, this containerization, who was the brain, whose brainchild is this? Linux, Red Hat. Red Hat Linux has started with the 7.0 version of Red Hat and the Ubuntu Linux. These are two very famous flavors of Linux, Red Hat and Ubuntu. They belong to two families. One is the Red Hat family, and that one is the Debian family. Anyway, so from Ubuntu 16.0 version and from Windows 8, containerization came into picture. So they are the first guys who started containerization. Linux introduced a concept of namespace and C group, the previous slide, to support the concept of containerization. Without the availability of this concept, namespaces are very important because they manage the C group resources. Every container is deployed in different namespaces. So this container will not clash with the container over here. They are residing in the same machine, but they do not have any resource contention because that is being managed with the C group and the namespace available with the containerization of the operating system or the Linux operating system. So once containers are created, they are very lightweight compared to the applications created on virtual machines, and we have discussed. Because the complete OS was installed occupying sizable amount of disk space, occupying huge resources, like with the entire OS being installed over for one application, the OS will take up a measurable amount, a huge amount, enormous amount of CPU, memory, network, IO, input and output. So all these things are very heavy. This application becomes very heavy. And specifically memory. So fine, we move on. We understood the concept. We have understood the concept. Revolution in application deployment. This is a revolution in the real sense of the term. This is virtual machine. You see the infrastructure is the same. Where is the difference? Instead of hypervisor, you have the Docker engine or the container engine. Docker is one company. Can you see the application size? The binaries and libraries and the OS kernel all will have to be there for this application to run. This application to run. This application to run. You have to have the full version of the OS installed again. Whereas you see this size has considerably, almost 100 times reduced because they are containers. Now, so what is the effect and what is the difference? So can you see this is a Docker? This is a very friendly whale. Did you ever hear the term or the name of a picture called Moby Dick? There was a famous US movie called Moby Dick. There was a very friendly whale in the Pacific Ocean, or rather, I think in the Atlantic Ocean. Yeah. So that whale, some ship which is getting lost. This is a story behind what happened. So the ships that got lost in the Atlantic, because Atlantic had a very rough weather. So usually the ship would deviate from the route. That time, with this distraught ship came the Moby Dick. There's a white whale. It's a fiction, you can see, or rather a story. So there came the Moby Dick from somewhere, and it guided the ship to the particular route. So some ship who was wavered in its direction, so wavered from its own path, now had the help of that Moby Dick, who had guided the ship into the track. So the entire Docker, this is named after the Moby project, famous project, which has given Docker to us. Okay. So this is the famous whale. So they have adopted the shape of the whale. This is called the Docker with the containers. So this whale is carrying the ship with guiding it in the correct path. So you can see the Docker has deployed your applications correctly, and the applications are put inside the containers. So where the Docker images, which is couple of MBs, the virtual machine images are couple of GB. So you can see the difference. Containers take seconds to start, whereas the speed of the virtual machines will take minutes to start. It is a bottleneck. When you come to today's applications, you cannot afford minutes, okay, for the application to be in picture. Yeah, I have crossed it out. Compatibility only with Linux distros. Distros means distributions. But whereas VM is applicable for all the operating system available in the market, that is with Linux, Windows, and Linux and Mac. But this is not true. Now, what Docker has done is that they had made the containers. They are building the containers in such a way that it can be not only on Linux, it can be distributed on Windows as well as on Mac. So you see, if you have a Docker engine hosted over.
Sorry to interrupt, Mr. Devashish.
Yeah.
I think it is it is already 2 hours, 15 minutes over.
Yes.
So
I'm very sorry.
one of our students, he mentioned ping me personally that as this
Sure.
other thing. So
I will stop the. Yes, sure. Go ahead.
So I think we can, if you have any questions, we will stop the progress of our coursework now from here, and feel free. We will have some 5-10 minutes Q&A session. If anyone and have any question or doubt, feel free to ask. And
So, Mr. Menon, can I stop the recording?
Yes, you can. We can stop the recording.
Yeah, I've stopped the recording. I will stop the sharing as well.
Yes. No, keep the sharing on, please. Okay. So, guys, do you have any question, any doubts? Anyone?
Not only doubts, you can ask any questions, whether it is pertaining to this subject or something outside the subject.
Any IT related question you can ask.
IT, yeah. I will stop the camera.
Next session, when will be conducted?
It is, we'll for DevOps every Saturday this time.
Okay.
So
means in a week once time you will take the session, right?
This free session, yes. Our main session, our main training session, which is paid definitely. That is Monday to Friday, 5 days in a week, daily 2.5 hours.
Okay.
Now we are planning to start our cybersecurity internship program as well, data AI, data science and AI, and data analytics as well. So I think next weekend, Saturday, Central Time, evening Central Time, we are going to start cybersecurity 1, and that will be Sunday morning for IST. So those we'll update, I think 1 or 2 days. Feel free, people have interest, feel free to join. And our trainer, Mr. Kalkey, is lots and lots of years of industry training experience. He used to be a very profound instructor in industry, in corporate level as well. He used to train DRDO. Those are based in India, they know about DRDO. So he used to be a trainer for cybersecurity aspect department in DRDO as well. So I have also, there is a coupon code is available. Those are the interest to register for our DevOps main course. This coupon code is valid for only today. Just check it out if it will help. Guys, you can also ask or discuss anything you are facing any obstacle during your job hunting process as well, right? Okay then. Thank you, everyone. Thanks a lot, Mr. Devashish.
Okay, thank you. Thanks all of you for joining on
I
a
think no one
Saturday
has
morning.
yeah, I think no one has any question for now, because today we have already only done the hands-on. Tomorrow, the next weekend, we are going to start from Docker, and see you then.
Thank you, sir.
Yeah, thank you, sir.
Thank you.
Awesome.
Most welcome.